All right, we're ready to get going. Thanks everybody for coming. Why don't I do the announcement I've got, and then you do your announcements, and then I'll introduce Rishu. Is that good?
That's good.
Cool. Great. Okay. All right. Thanks everyone for coming. This is the Seattle Postgres user group, and I'm glad you guys all made it out. The weather was a little crazy. He had to shovel his driveway for like an hour today. To get
Oh,
here.
more than that.
He was on the east side, but I heard it wasn't too bad downtown. I'm in Shoreline. We had some snow, but I didn't have to shovel. Okay, quickly announcements. A couple important things. It looks like everybody got a name tag. If you missed it, please do. Just kind of helps us be able to see who everybody is. Helps you all see who everybody is. Bathrooms, if anybody needs to find the bathrooms, you go back behind the desk, and there's bathrooms to the right and to the left down that hallway. Actually, I think there's some through that door too. I spotted them. Yeah, they're kind of all over the place. But yeah, backing out. The sign-in sheets. Please do put your name on the sign-in sheet. That's actually, so two things about the sign-in sheets. First of all, it's mainly just so we can kind of count how many people came, so we can see how many people came and we get a good sense for how much pizza we need to order. There's no place in the sign-in sheet where it asks for contact information, so you won't get any updates by signing in, or anything really, because it's no contact. But please do put your name down so we know how many people came. For updates, you go to meetup.com/Seattle Postgres, and it's on the sign-in sheet. And that's the place where we always post our meetups. We'll send like email notifications out, things like that. So that's the place you go for updates about the meetup, is to the meetup.com site. Two more things. There is a library in the back corner next to the pizza. If you didn't see it, it's just kind of a random collection of mostly database related books that we have. There's some Postgres stuff. There's some of it that's just general relational database theory, a couple of random other things that are a little broader computer science. You're welcome to borrow books from the library. It's kind of an on your honor kind of thing. Appreciate it if you can stick your name, email address, and phone number on the clipboard so that if it doesn't come back in like a year or something, I can just send you a text and be like, how's that book? I think I don't mind, as long as you're actually reading it, that's all. If you just like totally forgot, I might be like, let's bring it back. And then there is one more thing I like to mention. There's a little sheet of paper next to the library called the Happiness Hints, which you're welcome to grab one and take it. The Happiness Hints are a collection of slightly opinionated best practices for Postgres. That's like my compilation of like things that I've accumulated over the years. They're not all things that I thought of. They're just in fact, a lot of them are stuff that is widely agreed on sort of in the Postgres community, and it was just something that I started trying to write down in one place because I needed to do that for myself. So feel free to grab one of those if you'd like.
And there is a soft copy also in your blog.
That is true. There's also a copy up on my blog as well. There are a number of events coming up, and I think I'm going to pass it over to Lloyd for that. You want to go over events and anything else?
Yes. So PostgresConf is coming up in March in Orlando. While it states it's a 4-day conference there, your conference ticket only gets you in Wednesday, Thursday, and Friday. On Tuesday is tutorials that you pay extra for. Those tutorials will come out and be listed and available for ticket purchase Tuesday. Well, they say Tuesday, but I say on Wednesday of next week. I know that because we had a organizers meeting today because I'm on the board of that conference. So yes, that is supposed to be out on Wednesday of next week. You should be able to purchase the training tickets in addition to the conference tickets. But what we do need is some volunteers at the conference to do things like room monitoring, where you count the number of people in the room and you hold up flashcards to say, oh, hey, you've got 15 minutes left, you got 5 minutes left for the speakers. We don't pay the airfare or hotel, that's up to you, but you don't have to pay for the conference. And you get to sit in and watch the presentations. So if that's of interest to you, you can talk to Debbie at postgresconf.org. Come see me afterwards. I can write down the email address for you and hook you up with her because she's the head of the volunteer group to do that. Switch to the other one. PG Dev is in Montreal in May. If you really want to understand the internal workings of Postgres, This is where developers from around the world go to talk about what they're working on for future releases of Postgres, or what they've just completed that will be out in the next release of Postgres. The developers get together there. They have an unconference there also. So if you really want to talk to and influence what happens in future versions of Postgres, this is the conference you want to go to. These other conferences, like in the US, are where you go to learn how to use Postgres. This is where you go to influence Postgres. I've gone there plenty of times and have complained about features and gotten new features added to Postgres to fix issues that I've had by being able to talk to people who are working on the internal code of Postgres, which you don't get to them at the normal conferences in the United States. Also, we have the date for the conference in Sydney, Australia. It'll be October 17th. It's going to be a single-day conference. This is its first time starting back up since the pandemic. Malcolm, who ran the South African Postgres conference, is hooking up, who moved to Australia during the pandemic, is actually hooking up with the people who used to run PG Down Under to get a conference back going. It's not going to be exactly the same as what it was. It's going to be a new conference, and will actually run under the Postgres World banner, which is the Postgres Conf that you saw in the first slide. And the Orlando one will be kid-friendly because it's going to be directly across the street from Universal Studios. In fact, we are ordering in a bunch of board games for a board game night that family is also welcome to attend, not just people who are paying for the conference. So, and there will be a family pool at the hotel and everything. So yes, you can bring your family to that conference. Well, not to the conference itself, but to the hotel and to enjoy everything else that's down there at the same time. Okay,
cool. All right, lots of stuff coming up. For tonight, we're going to kind of do this in two parts. So Rishu is going to have some presentations to do first, and then after Rishu does his presentation, we thought this would be fun to do. I'm going to grab my laptop and pop up too, or maybe, I don't know, you can hang if you want to. And what we're going to actually do is just pull up a copy of Postgres and Docker on my laptop, throw it up on the screen, and start demoing a whole bunch of the stuff that Rishu talked about, and also just sort of demoing how you can look at some of the internals of Postgres. So, so Rishu's going to first do some speaking. If it doesn't all make sense to you during the talk, because he's going to talk a little bit about some internal stuff, then stick around and watch us sort of pull some of it apart on the screen, and maybe that'll help kind of connect some of the dots too. I think it might. So I've talked about Rishu a bunch of times. Let me quickly introduce him. Rishu is a software engineer who has worked on open source Postgres and also worked on Amazon Aurora related Postgres related projects. And specifically, Rishu worked on the open source efforts in Postgres to move what are called SLRU pages into the main buffer cache, and also to add page headers to the SLRU pages. Now, if that doesn't make sense to you yet, that's okay. Rishu's going to talk about it a bit, and like I said, we'll sort of tear things apart a little bit afterwards. Thank you, Rishu.
Thank you. Yeah, so today the presentation is about transaction metadata in PostgreSQL. Yeah, so just a little bit about me before we get started. My name is Rishu, as Jeremy mentioned. I used to work on Aurora Postgres at AWS. That's where I met Jeremy, and that's why we're here today. Yeah, I graduated from U of I in 2021. I really like distributed systems. I feel like it's not just a problem related to computers. I feel like they really model problems in how humans communicate and how everything's actually happening in real time. And distributed systems help us understand how communication works. And that's kind of why I like it. Outside of software, I really like music production. I like making beats. I play the piano. I play tennis. well, the table data. So yeah, that's a little bit about me. So yeah, let's get started on the talk. So before we talk about the transaction metadata, let's just talk about what transactions really are in Postgres. So if you've ever heard of the word or phrase ACID, transactions are the key part of that and what drives ACID. A transaction in simple terms is any atomic change to the database. So it's either all in or it's all out. There's no in between. There's no like, some of this change got in, some of it didn't. No, it's all in or all out. And in Postgres, all of the write transactions have a unique 32-bit transaction ID. And so here we can just see an example of a transaction. So it begins with this command, begin. I can do some inserts into a table, and I can commit. And one thing that Jeremy and I were talking about yesterday is actually in Postgres, one thing that's pretty neat about transactions is that you can do transactions that operate on different tables. So here, like we're inserting into the numbers table, and we can insert into strings, and this can all be part of one transaction. This image here just kind of helps show how transaction IDs work. So they're sequential. There's always a current transaction ID. Anything past that transaction ID is invisible. The system does not really know that it's there. It doesn't really come up in part of the system. So if you see a tuple with a transaction ID that's past the current transaction ID, it's not valid. It's not able to see that tuple. Also, these transaction IDs actually go in a circle. So there's a limit, which is basically the size of an integer on what is the last transaction ID, and then it goes and starts over at 0. So if you've ever ran into this issue of transaction wraparound, that's what this is, where a transaction is kind of, you've ran out of transactions to use, essentially. And that's kind of a bigger issue. We won't really cover that right now in this talk, but if you've ever heard that term, that's what this means. So yeah, let's talk about what we're going to do today. So Postgres stores a lot of metadata about transactions and it stores them on disk for durability. And it caches a portion of this metadata in memory for performance reasons. There's a lot of transaction metadata, but today we're going to be talking specifically about these three, which is the commit status of a transaction, which is stored in, if you can look at the source code in clog.c, the nesting status. So if you have parent and child transactions, that's in subtrans, so that's called a subtransaction. And if multiple transactions are accessing the same row, we call that a multi-transaction. So we're going to cover these three topics today, just to show like how, where these things show up in the Postgres memory. These are like this is like a very elementary division of how memory works in Postgres. We have the transaction metadata, which uses a SLRU cache. SLRU is short for simply least recently used cache. So it just evicts, it's a caching mechanism which evicts whatever page that was not, which was least recently used, right? And there's another cache, which is like your main user data that's stored in the buffer cache. And that uses a different algorithm for evictions, and that's a clock sweep algorithm. So it's a little bit, it's similar to LRU, but it's a little bit different. And then there's a whole bunch of other caches that we're not going to get into right now. Within these SLRU caches where our transaction metadata is stored, there's these different types of metadata. And so there's the clog, there's multi-exacts, and there's subtransactions, predicate locks, which is used for snapshot isolation, which I won't talk about right now. Maybe Jeremy might want to demo it later. And async notify, which also is not really related to transaction metadata, but it's also cached in the SLRUs. But yeah, we're going to mostly talk about these first three today. So I kind of went through all that fast. Are there any questions right now? Cool. Yeah, so talking about commit status, there's four total statuses a transaction can have. And these it's either in progress, it's either committed, it's either aborted, or it's subcommitted. So the first three are pretty self-explanatory. The fourth one is basically used for subtransactions. So a subtransaction can be marked as subcommitted. Subtransaction commits, it's marked as subcommitted. It doesn't necessarily mean that it's visible, because the parent transaction might not have committed. So we use this number to denote whether a subtransaction is committed. So this is just an example of how the commit status might look. So at T1, we have transaction ID doing a commit. And so this gets marked as committed. And at at time T2, we have transaction ID 201 doing an abort. So at time T2, it's aborted, but at time T1, it was in progress. So essentially, it's just an array of bytes that show what a transaction's commit status is. So we can take a deeper look here. If I inspect the C-log file directly on disk, we see here that we can examine the C-log files that are stored in this folder called PG exact. So if you have your Postgres running on a cluster, mine is called PG debug. And if you look inside the data directory of that folder, you can see all of your data for that for your cluster there. I can actually just show you really quick here. So yeah, so here we have all these folders, right? And so if we look at base, this is going to be all your user tables, right? We can see all the relation data here. If we look at PG underscore exact, this is the C log. And so we can look at just command here. Anyway, so we can just do, we can see all of the data. We can see all of the C log data in this file. Yeah, so you might be wondering, what are all these fives, right? And so 5 in binary is, or what are all these? Yeah, so 5 in binary is 0101, right? And we mentioned here before that this 01 is a committed transaction. So when we look at all these fives, what it's telling us is there's a bunch of committed transactions in a row. And we see here that the last transaction that we have information is right here. So if we were to do the math of looking at, okay, this is at byte C0, byte offset C0, and it's on the last number here, right? So if we do that calculation, I'm not going to go run through the math right now. I have the math right here. We can see that the latest transaction ID here is 783. Does that make sense to everybody? Yeah, so yeah, that one's pretty simple. This one's a little bit more interesting. So we have subtransactions. Subtransactions basically store each transaction's parent transaction. And if the parent is a top level transaction, then it's not, and it doesn't have a parent, then we're just going to store a 0 there, and that's invalid transaction ID in Postgres. So each transaction ID is 4 bytes, and every XID is basically mapped to its corresponding page and byte offset on the subtrans page. So very similar to the C log, except instead of 2 bits at a time to store the information, we're now using 4 bytes at a time. So an example of how I might generate a subtransaction, I can just have a begin, and that starts my top level transaction. I do a save point, SavePoint will basically create a subtransaction, and this will be part of my subtransaction, this insert statement. And when I commit, that whole transaction commits. And so, yeah, taking a look again. So if I dump out the contents of the subtransaction file, I see that I have a bunch of zeros. And then I finally have a non-zero value right here, which is like 306 in hexadecimal, right? And where is this? This is at C10 plus some offset, which I calculated, and that's 3088. So what that means here is that this is the entry of a subtransaction with transaction ID 3088. And the value at that entry is 306 in hex, and 306 in hex is 774 in base 10. So we can see that, okay, this subtransaction ID with 3088 as its transaction ID has a parent transaction, which has a transaction ID of 774. Everyone following on that? Yeah. Sure.
Why do you function that much about it?
Yeah. A user can issue a transaction that has a subtransaction that's part of it. And one thing that might be very something you might have seen is like if I do a select star from X where, and then I do a nested select statement within that, that would also generate a subtransaction if I'm not mistaken. Another thing is like, again, with save points, if I mess up a transaction and I want to roll back to a certain point within that transaction, that's also a subtransaction where I have one nested transaction, but I have a parent level transaction that's contains that. So I don't write that much SQL. I mostly have worked on the source code, but I don't know if Jeremy wants to answer that question as well.
One really common, so I don't think subqueries do it, but the second one is like, that's like the big thing is that you can roll back partway, or like if you hit a syntax error, even like you can just go back to before you had the syntax error and then continue on. But the big thing with subtransactions is that there are some drivers, like client drivers, that will have an option to automatically wrap every statement in a subtransaction, and it's partly related to how Postgres does error handling. It enables the driver to say if the statement generates an error, it can just kind of like roll back from that statement and then give you the option in your application code of what you want to do. So you could tell your application to handle the error and continue on without aborting your whole transaction and having to throw, sort of lose the whole thing. And the thing to really look out for is some client drivers don't tell you that they're doing that, and they might be using subtransactions and you don't even know it.
In Postgres, we have functions, and inside the functions, you can trap errors and spit out a message, but actually continue and complete the function so that the function still commits. So that's would be using the subtransactions inside of the functions.
Cool, thanks for the question. So moving on, multi-transactions. These are pretty interesting. I really like how these work. They're pretty neat. And they're a little bit more complicated than the first two types of metadata we discussed, which was the commit log and the subtransactions. Those were pretty much just an array of information stored as raw data in our pages. These are a little bit different. And the way what these are used for is essentially if multiple transactions are trying to access the same row and they all have shared lock on a same row. So there are different types of locks. We can get into that, but there's essentially, just to simplify things, you can have an exclusive lock, which means this transaction has a lock on this row and nobody else can access that. They can't even read it. Or it can have a shared lock where multiple transactions can be accessing that row, but nobody can get an exclusive lock on it if there's transactions that have a shared lock. So with multiple transactions that have a shared lock, we have a problem, is that we would want to know all the transactions that have the lock on that row. But for a row, there's only one field. There's only one transaction ID that we can store that tells us who updated this row or who has a lock on this row, right? And so how do we solve this problem of we want to know we want to know a list of transaction IDs that are accessing row, but we can only have one transaction ID that tells us who is updating the row currently or who has a lock on the row. And that's stored in this like xmax field. If you select xmin, xmax from any row, it'll tell you the xmin and xmax. And xmin is basically the transaction that inserted that row, and xmax is the transaction that did either an update statement on that row or a delete on that row, anything that's modifying that row. So in case anybody doesn't know this about databases, there's never any tuples that get modified. Tuples are immutable, right? And so we want to basically just create a new tuple with a new value instead of deleting or modifying any old tuples. And the way we do that is we have this like metadata about a row, which tells us the transactions that are modifying that row. And when we look at the xmax, if the xmax isn't empty, we can see that, okay, this row is being updated or is being deleted. That lets the database know how to handle visibility issues. So what happens with multi-transactions is what we do is we take all of those transactions that are trying to access that row and we create another type of transaction called a multi-transaction that is a separate, unique transaction that's going to be some sort of like, think about it like as a parent of these multi-transactions. And so from that multi-transaction, we have a data structure that we can access to go from getting the multi-transaction to a list of all the transactions that it's part of, that are part of that multi-transaction. So just a diagram that kind of shows this. There's two data structures used to handle multi-transactions. And it's kind of similar to a hash map in a sense where you have the key value, which is like your multi-transaction, and you have your members, which are the actual data store of the list of transactions that are part of that multi-transaction. So we have the offsets and members list. And so the transaction ID comes in. Using the transaction ID, we calculate what transaction ID maps to what offset, what value in offsets. Offsets will tell you where to look in the members list. And the members, when you look in the members list, you can see all the transactions that are part of that multi-exact. So yeah, taking a deeper look into the actual files here. So we can see these files in the PG multi-exact folder within our data directory. And we, as we mentioned, we have two different types of data structures used to get our multi-exact information. We have the offsets and members. So we have two different folders here. So if I look at the file, the first file, which is just 0000. Sorry, give me a second. Everyone's trying to call me right now. Okay, sorry about that. Yeah, so if we have a bunch of these files, so here we see that we have an entry in our offsets which is 1, right? And so, sorry, we can see here that this is at offset 1. So this is for, I think, and I just didn't update this, but this is for multi-exact ID 1. And for multi-exact ID 1, we see that its offset is also 1. And so we can look into the members at offset 1. So this first set of 32 bits here, that's just a member header. And 0 is never used for concurrency reasons. And so we can see our data here for the information about what transactions are part of this multi-exact ID with ID 1. And so we have 303 and 304. And so these are the XIDs 771 and 772. Yeah.
So is the fixed data size to keep track of the number of transactions? Or how do you track it?
Yeah, it can so the total size of the multi-exacts, like the entire directory, is at some point that was capped. In recent changes, it's been like dynamically resizable. Like we're not dynamically resizable, I shouldn't use that word. But in the conf file, you can set like how much data you want to allocate for multi-exacts. And then there's no limit on how many transactions can be part of a single row lock. So as long as you have space in your multi-transactions directory, that'll be fine. In the cache, yeah, the directory can be larger size. Yeah. Yeah. So yeah, the latest changes around this these mechanisms in Postgres. I think the most recent one was resizable SLRUs, and that also came with bankwise locking. That was developed by Dilip Kumar, Andre Bruden, and Alvaro Herrera. And so what that did really was previously your SLRUs were a fixed size in memory, and you couldn't really change how much you wanted to allocate in memory to these data structures. And now you can. So I can make my C log really big, or I can make my multi-exact really big, depending on my workload. Or if I have a workload with a lot of sub-transactions and I need to access these types of files really efficiently, I can allocate more space in memory for that. Also, previously you would basically get a lock for, if I was making any C log update, I would get a lock on the entire C log structure in memory. And now with this new feature, basically the C log is partitioned into different banks. And so I can just lock a specific portion of the C log segment in memory. And that allows for faster, allows for better concurrency in the database. The other patch that is around this is the one I was working on with some folks at eBay. So we were trying to move the SLRU to the buffer cache, also for performance reasons. The buffer cache, as I mentioned earlier, that's a different cache, a whole different caching mechanism. And the main thing is that that's dynamically resizable. So we wouldn't have to kind of like tune the SLRU sizes, and it could just kind of take away space from the buffer cache as needed for other relation files. That has kind of been stalled in favor of the other patch. But we're still working on getting in the portion of this patch that introduced page headers. And so page headers were important for this patch because we wanted to kind of have the SLRU pages in the same format as the regular relation pages. So as you saw, like as I was showing, the data is basically stored in raw data structures on like a file. There's no sort of page header. There's no file format really. And so we want to add these page headers to make it work like the rest of the pages do in Postgres. And one added benefit of that is having durability. So currently there's no checksums, because checksums are in the page headers, and if there's no page headers, there's no checksums. So adding the page headers also adds checksums to our SLRU pages, which kind of ensures data consistency and correctness of the data. And yeah, that patch is still currently in review. Yeah, and yeah, that's what I had to talk about. Yeah. I think Jeremy wants to do some demos as well.
We're gonna play around with questions.
Before we go to the question about C-log, so
Sure.
You mentioned that the transaction ID is 32 bits, so technically we have like 2 to the power of 32 number of transactions.
2 to the power of 32 number of transactions?
Yeah, because
Sure.
the transaction ID
Yeah,
is
yeah, that's the max transaction.
Yeah, and from how you showed the C log, it looks like there is 2 bits per
Yes.
one
Yeah.
transaction.
Yeah.
So does it mean that we can have this file can go to the 1 gigabyte to accommodate all transaction from 0 to?
You can have C-log wraparound earlier. So because there's, well, no, C-log will always have more. Yeah, C-log is never going to hit that issue because
Are
of
you asking if
transactions.
it's a single file that stores all the bits versus multiple files?
C-log is a buffer,
Actually, I don't know. So
Yeah.
I'm
It's
just
split
curious.
across
Like, is it
multiple
going to
files.
be 1 gigabyte in size?
Is it good for the C-log
Is it
page?
going to be?
No.
Is it going?
Is it going to grow to the
right?
1?
No, because
Why not?
Vacom cleans it up, right? You run Vacom and cleans it up.
Yeah,
Yeah.
so the commit log, this gets in, this is fun. So I kind of want to like play around and demo some stuff, but this also comes into like, when is it safe to remove the C log? Which is a question you have to think about, like, yeah, at what point do you no longer need that information and can it be removed? Because it's circular. So at some point it's not needed anymore, but you do, like the database has to know for sure 100%. And this is directly tied to vacuum, because what vacuum, one of the things that vacuum does is it stamps, like it's called freezing. But one of the things that freezing does is it basically stamps all of that information about whether transactions are committed or not directly into the data file, so you no longer need it. Because the basic reason you still need the C log later is when I read a data page, I see a tuple. I see it says, welcome to SEAPUG, right? Row number 1, welcome to SEAPUG, and then tells me transaction ID, but it doesn't tell me what happened. Was that committed? Was it aborted? I don't know. So I see this row, but I don't know what's the status of that transaction. So I have to go look in this other data structure to get the status. And then I know, should my query return it or not? Now, eventually what vacuum will do later, come through, and it kind of tries to do it kind of efficiently in batch. It just kind of sweep through the whole thing and do it all at once, is it'll take and literally update the record in the data file with the final status of the transaction. At that point, once you know the final status has been written in the data files, and you have to be 100% sure that there are no references anywhere. At that point, it's safe to remove the C log, because you won't need it anymore. You won't need to go back and look at it because the information, but you really have to be sure, because there is, like, if there are, and there have been bugs, you can actually find 1 or 2 emails on the hackers list from like many years ago. There's a specific error message you will get if it hits a row and it needs to try to look it up in the other data structure, and it goes to the commit log data structure and it's gone. And it's like, oops, that's not good. Now you can't find out.
So,
And
what
that's
you're-
essentially a data loss situation.
So what
Almost.
you're saying, there is some variable which says which transaction number is in the offset 0 in C log?
Offset 0 in C-log would just be XID 0. So it's like, it's just a math. So if I have XID 0, I would figure out.
So if I have
Yeah.
a transaction ID 3 billion in my database, does it mean that the C log will be the size of 3 billion divided by 4?
Well, to start with, 3 billion is past the like largest XID value. So it's like 2.7 billion is 2.7 something billion is the like largest XID you can have.
204. 32
32-bit is, but we have it's unsigned bits,
Is
right?
it signed or is it unsigned?
The unsigned, the largest unsigned number would be the highest number, but remember it's circular. So, and this is like one of the really important fundamental concepts of Postgres, is that transaction
So the
IDs
3
go in a
billion
circle.
is less than 2 to the 32.
But the math, there's a define in the Postgres code, and there's a function that says, is this transaction ID before or after this one? And it's not a greater than less than, because you can't just do the math like that, because after you get to 4 billion, I think it's 4, it just has to go right back to 0, and it's a circle. It's just a circle. So the before after math, like, is this which of these 2 transaction IDs, what order do they go, has to account for, like, the number could be bigger, but if it just went over the line and back to the beginning, like this, even though it's a smaller number, came after. Does that make sense?
Yeah, that makes sense.
Yeah.
Yeah,
I'm just trying to understand.
It's super weird. You have to like visualize that circle that he had on his slide, and those things always it's like a clock. Like, just the hands always go around in a circle. And And so there's always like, it's not like there's ever 4 billion of anything anywhere. Like vacuum is coming along at the back, sort of cleaning things up. And then on the front end, you have your workload that's like pushing the clock forward by creating new transactions, creating new data. And the thing that they call transaction ID wraparound, which is like the big, scary, hope it never happens to you, it's cataclysmic, because the big thing is you have to shut down your database until it's fixed. So it's usually an outage. Well, you don't lose data, but it's an outage usually while you fix it. It doesn't happen very often anymore. It used to be a bigger problem. The reason that happens is that cleanup process can't keep up. So like the cleanup always has to bring the tail around on the clock. And if it can't keep up, like if your workload is creating data too fast and the cleanup process is not able to keep up, and if it gets to that, there's a line, and it's like a straight line on a clock. Like the tail can never be more than halfway behind. So the maximum, you think like 6 hours on a clock, like that's the maximum of how far back it can go. It's like a credit card. You can only charge so much on the credit card, and then it's like the bank is like, nope, you have to pay it off.
I think
There's one point, the account freezes the rows, and you can press actually transaction ID 2, transaction ID 2, which is always visible, right?
That's the frozen one, yeah. There were a bunch of hands kind of in questions. Yes?
Is that the same thing as like integer overflow?
Not exactly. I think like the similar concept in the sense of like an integer overflow is like more than, you have like a threshold and you've gone beyond that threshold and the system can't handle it. But I think beyond that, I think it's a bit different because of the sort of circular nature. It's very specific to Postgres. Like just like I think that like a clock with sort of two hands on them, sweeping around. One hand is your workload, moving the transaction counter forward. The other hand is vacuum, cleaning up behind, coming out of the back. This is also a reason, by the way, it's super important that like there is occasionally you'll see advice on the internet that says, oh, if vacuum is using too much CPU, just like shut it off or like turn it down or like, slow it down so it doesn't use so much CPU. And that's generally a very bad idea because of this reason. Vacuum is crucial to your application. And you usually, there are a couple cases where people who really understand what they're doing might sort of like more take a hands-on approach to managing vacuum. But you don't want to just like, oh, lots of CPU, I'm just going to shut it down. Like that's totally the wrong approach. Other questions?
Before that, I do want to mention that like the CLog page, so each page in the SLRU, it's like a segment, and each segment is 1 gigabyte. So it won't grow past 1 gig, like a file won't grow past 1 gigabyte, if that's what you're asking. Yeah, so it'll just create a new file if it needs to move on or a different transaction ID. But I feel like for CLog, that shouldn't be an issue, right? Because a gigabyte should be enough to store any transaction ID. Because each
Technically,
byte.
it should be there to store all transaction ID, but I'm just curious from, probably I just misunderstand. Some lower transaction ID is not used, so.
I want to, let's keep doing questions, but like, part of what I wanted to do was like show you guys, because this is so easy. It's a lot easier than you think to experiment and yourself. If you brought a laptop and if you have Docker on it, get on the guest Wi-Fi right now so you can try this with me. Now, what other questions? And then Rishi, you answer questions.
We were also talking about size of an integer. So it's 2.1 billion net positive and negative. So that would be 4.2 billion unsigned, which would be your number that you're looking at.
But what I do remember is that if a transaction hits 2.7 something billion, that's when we officially say, okay, wraparound has happened.
Yeah.
Because we're not allowed to go past that.
Well, that's the 2 billion.
Yeah.
Is the 6 o'clock thing.
Yeah.
Like the vacuum can't be more than halfway behind. So 2 billion is half of 4 billion.
Yeah.
So if vacuum is 2 billion transactions behind your current transaction, that's where Postgres shuts. It just literally shuts down. Like it just stops. It's like, I will no longer allow you to modify data.
I mean, you can start up the simulation mode, right?
And so what they do, there is a safety margin that they built in of X number of transactions because you still have to finish the vacuum to get out of jail. So you do not want to like abuse that somehow. The purpose of, although I think too, I don't know, I mean, you might know this, I think now it will continue vacuuming. Vacuum will keep running even if you don't shut it down and switch to single user mode, because it will self-heal. Like if you didn't know, you weren't paying attention, and it went into wraparound and stopped accepting transactions, and you just like, you had no idea, like probably by the time you logged in the next morning, it might already be fixed, because it will just finish the vacuum that it's running.
We don't need to go in a single user mode in this case, because vacuum doesn't consume any transaction ID. So even if the
Okay.
vacuum transaction ID reaches the limit, what we need to do is just vacuum. We can consume any transaction, but the vacuum doesn't consume.
Yes.
So if you just stop new transactions, right, that's kind of the problem.
Yeah, the database doesn't accept any writes,
Yeah.
but accepts vacuum.
That's
Jeremy? So when you have a tuple, it's inside a tuple that the transaction IDs are written into it? Because I'm trying
Yes.
to find out if it is there, and each transaction identifies who the user is, the connection it is. So does it mean that in theory you could find out who added the record, updated the record? But the problem is, how could that work if there is recycling of the transactions because of looping?
I don't believe Postgres keeps track of who did each transaction.
Yeah, no, it doesn't.
It keeps track of who's currently signed in, authenticated for a given session, but after that, it doesn't.
But after that, the transaction ID is still left on the tuple, but it may not make any more sense.
The transaction IDs are always on the tuple. In fact, if you're interested in these things, look under system fields, and you'll find a whole list of system fields that are on every tuple. And you can, if you just do a select star, they're hidden. But if you specifically call them out on your select statement, they will appear. Like the xmin and the xmax are just two of the system fields that you can gain access to.
And one last question, is there any impact with isolation levels or any interactions at all?
Oh man, isolation levels. That was exactly the one that Rishu was talking about earlier, that he said we weren't gonna dig into. Short answer, what's the short answer to that? Like isolation matters, isolation levels do matter. Postgres really supports 2 of the 4 isolation models. I mean, nobody supports 4 of 4 because dirty reads are like more theoretical. It's not like a real thing that databases implement. Isolation models, for those of you who aren't familiar with this is kind of like relational database theory from like the very beginning of relational database era. And like one of the things they defined as in the academic world as they thought about relational databases, how it works, was consistency models and what they call isolation levels. Let me just real quickly.
The idea is how independent you want transactions, right?
From
Well,
multiple
there's a
people.
table. There's a nice table in the
Yeah.
docs. The Postgres docs are fantastic. If you don't spend time in them, it's worth it. There's a doc here called, this is just from the Postgres documentation, transaction isolation. This explains it very well. So the SQL standard defines 4 levels, and there's a table. This is the table. So Postgres, yes, this is going to impact things because if you switch so Postgres defaults to read committed. If you switch it to serializable mode, like it has to do that somehow. It has to, so and that was actually the last SLRU, what are called predicate locks, which is related to serializable isolation, which was in Rishu's slides, but we just didn't dig into it. So it does overlap. I don't know if we'll.
Should I try to maybe explain a little bit what it is in a more simple fashion? So if you have a long transaction and you're doing a bunch of changes, are any of the changes grouped together to be visible by other people or not?
The changes, so this is, yeah, okay. What you're getting into is what are non-repeatable reads, what are phantom reads, and what are serialization anomalies. That is not any of those things. So the updates, the basic rule of like atomic transactions or atomicity, this is the A in ACID, okay? is that the transaction is atomic, the updates are grouped together, and the visibility of those updates is also all or nothing. It's not just that the updates go into the database all or nothing. You could update 6 different tables, right? You could update 200,000 different rows or 1 million different rows in those 6 tables, but like until the moment that you say commit, if the system crashes, it will be as though you never did anything. And then the 1 millisecond after your commit finishes, if the system crashes, all 200 million of those updates across all of those tables, which this is like, don't underappreciate this, because this is, to do this across lots of different tables is a really hard computer science problem to solve that most distributed databases still have trouble with today, right? Like across tables, you know, coordinating transactions across shards, across things, like this is a hard problem to do in a performant way.
But in the transaction that you're currently in, the question is, can you see values of other record that may have been committed while the transaction occurs, or do you only want to see the changes when you started your transaction?
So, okay, what you're, now your question, you're really good, Eric. You know exactly the questions to ask. It's like forcing me to talk about transaction isolation levels, even though I was trying so hard not to. All right, yes, can I just, dang it, as long as we're gonna get into this, you know what, here's the deal. Let's just show everybody what this is. Like, let's just run the queries and like demo it, because it's much more clear to see it than to try to explain it. So I've become a fan of Docker. If you have Docker on your laptop, you can literally follow along and do this right now. It's super fast and easy. I did the long commands. There are short versions of these. Detach means run it in the background. Otherwise, it would just sit here and print out the logs on the screen, which would be fine, but I'm going to detach it. Giving it a name is just kind of a thing. It'll make my future commands easier to write. The little publish line there, what that means is that there's a port that Postgres listens on, and I'm just asking it to sort of map that port and make it visible on my laptop. So I could connect to this Postgres running in the Docker from the outside. If you use, there is a standard Postgres Docker image. So the very last thing you type when you do Docker is, what is the image I want to launch? This is a cool thing about Docker. You can type like a big URL to like pull an image from like somebody else's container registry somewhere random. If you just type the word Postgres, nothing else, just the word Postgres, you will get the default Postgres container from Docker Hub. And that container, like you get the latest build of Postgres. Under the covers, there are some neat things happening there. I've gone through all the build scripts and everything and learned about how this works. It turns out like what you're actually getting in that container is in fact the Postgres build coming directly from the Postgres community and specifically from the Debian packagers. And from the Debian packaging ecosystem, but it's coming from the PGDG repositories, the Postgres community build system. It's not being built like externally, which is a really cool thing. It means you're getting the standard bits, the standard compiled bits. If you use the standard Postgres Docker container, there's one mandatory environment variable, which is called Postgres password, and that's where you give it a password. It won't start if you don't give it a password. I have no complaints about that behavior. So we do this. It's just that fast. If it's your first time running it, it'll have to download a couple of bits over the internet from Docker Hub, but it doesn't take too long. Plus, I'm hopeful, if I have time to write the commit that I want to write within the next 2 months before Postgres 18, then I'm going to cut that container size down by about 30% more. Because there's a low-hanging fruit, easy way to do it. All right, so now I can do Docker PS. You can see it's running. It's this. Like I said, if you have it on your laptop, do it. Follow along. This is how easy Docker is. It's awesome. I'm a fan, if you can't tell. I wasn't using this, by the way, until like about 6 months ago. I was 10 years late to the party. Everybody else has been doing this for like a decade except me. But I was off doing other fun things. Okay, now I can do Docker execute. I'm doing the short version this time. -IT says interactive mode, put it in the terminal, or give me a TTY. And now I can give it any command. I'm just going to say run bash. Now here's the fun thing. Wait, hold on. No, I forgot to give my container name. Test PG. That's my container. Now it's the bash. And we're in. Now I have no PS command because I'm running inside a minimal container. However, this is the fun thing here. I feel like this is cheating, but all the deviants and files are still sitting there. So I can run this apt update command inside my container, and I can pull down the entire I can update this, and then I can sit down and actually update my container. This is, you wouldn't really do this, like you'd actually just update the Docker file, but for a hacking session, like real time, this is a great way to go. So I'm just gonna pull a couple extra things that I want in order to demo some stuff. The 3 packages I pulled were BSD main utils. The reason I did that is that's gonna give me a handy utility called hexdump, which is just a more kind of like user-friendly way to look at the binary of the files. The watch program, I just like that if I want to watch a directory or something while I make changes in another window. And then something called Postgres file dump. This should really be in core someday. I don't know why, it's too bad you have to, I'll show it to you in a minute what it does. It's super cool. All right, so now I have some stuff in there. Postgres is running in here, but I do have to give it a username. And see, I can pull my Postgres. So, and if I, here, I'll pull up another pane over here. Now I'm back on my laptop here. So I'm looking at everything that's running on my laptop. You can see on my laptop, we've got containerd, which is the container daemon, and then you've got Postgres running down underneath, and I've got my PSQL command running inside of the container. So you can see from the outside that it is running on my laptop. This is a Linux laptop. All right, so that's how easy it is to get Postgres up and running. Now I was going to, my original plan was to like do some binary dumps and things, but Eric, since you're like pressing on the isolation levels things, let's actually play with that first. So isolation levels. I'm not a Docker yet. Docker execute -it test pg, and this time I'll just go straight to PSQL. We'll jump in. Okay, so now I have 2 Postgres windows. All right, I have no tables because I just spun up this container from nowhere, so let's create a table. Create a table, we'll call it SEAPUG, because that's where we are, and because SEAPUG is awesome. I'm not going to create a primary key, but I'm going to like make the columns because I don't want the extra indexes right now, just to keep things simple. But we are going to do a big int. Always use big ints, people. Do not use integers, use big integers. If you're in Postgres, just trust me, you're going to save yourself some headaches down the road if you just always use big integers.
And where I work here at the Hutch, we have run out of integers before in our database.
Yes, you can run out of integers. It's a bad thing when it happens. There's like multiple hands going up in the room. Yes, agreeing with this. Yeah. All right, so now I have a table. All right. Let's see here. What do I want to do? What we're going to do is to illustrate the. Gosh, I almost should do. Let's create a second table. We'll call it attendance. I don't know, do a date, ET, call it TS. I'm sort of cheating here. 2 text fields, name, text. All right, and here's what we're gonna do. What I'm gonna do is insert into the attendance table, insert into attendance, and I'm just gonna put 1 row in here to start with. So today is February 6th. February 6th meetup, and well, Lloyd is here, so we'll put Lloyd in the attendance table. All right.
Values,
Misspelled it.
Thank you.
not values.
What?
Yeah. Insert into attendance values, right?
Yeah, values. Yep, there we go. Okay.
He still misspells it.
It's consistent. It's
Here. You're right. You're right. You're right.
Chunk it.
Update.
You can just update his page.
Name equals. Lloyd. There. That's much better. Select star from attendance. All right. So Lloyd was here on November 6th. All right. Now, in my other window, let's see. How do I want to demonstrate this? Create table attendance summary, which is called with a CNT, which is a number. Okay. I don't know if this is the best way to do this, but it should work. It's not number. It's numeric, but I'm going to do big N. That'll work. So what we can do here, I'll try to demonstrate the serialization anomaly first. So I'm going to start a transaction. Remember transactions, it's all or nothing. And what I want to do is, in my transaction, select count star from the attendance, where say the timestamp is February 6th, all right? And I see what. So what I'm going to do is insert into the attendance. Actually, hold on a second. Drop that. I want to create that again, but I need to do one more thing. Not just the count. Let's give it one more thing. A description.
Still
Which
not
is a
the
text field. We'll just do this. Okay. That's a reserved word, of course. Just call it message again.
No, it's
Still
a
not the
number.
Oh, because I went to the wrong line. Thanks, guys. Live demos are the best. All right. Now, we start a transaction. So we start a transaction. In our transaction, what I wanted to do was get the count for today. So right now there's one person. Okay, so what I'm going to do is insert into the attendance, and this is going to be kind of a contrived, silly example. Why does it be insert into attendance summary table, values, and we're just going to say it was at meetups where there was only one person. These are not great attendance, okay? And I say, I know my grammar is wrong, don't worry about it. Okay, now I'm inside a transaction, right? Now, in the meantime, over here, we're still working on this, and it turns out Lloyd isn't the only person here, but also Rick is here too, right? So select star from attendance. Now this is, note, I'm not in a transaction. Like this is all committed data. Now let's go back to my other one, and I'm inside of a transaction, and I'm going to check my count again. Now I see 2. That right there is what's called a phantom read, specifically. Right? Did I remember this right, Rishu? Because we were looking at this right. I think I had it right. There's the phantom reads and there's non-repeatable reads, and I think this was the phantom read one.
Yeah.
Yeah. Because I'm getting inconsistent answers, and this is what Eric was getting at. Like, there's no question about, I'm not seeing partially committed transactions. That will never happen. So like, if I started a transaction and I made 3 updates and then I committed, those 3 updates always, invariably, are a unit. They're atomic. So under no circumstances will you ever just see 2 of the 3 updates in the transaction. But what can happen, and this is what you were getting at, Eric, is you can get this thing where you, within a transaction, you like run the same query twice, but some of the other commits suddenly show up. So like your view of the data can sort of shift underneath you. But there's a solution to this.
There's one more thing that I think we saw yesterday, right? Where if you do begin, like if you do a begin on the right, on the left side,
Yeah.
You do an update. You can see the update before it's committed.
No, we never saw an update before it's committed.
Okay.
And that won't happen either. For sure, that'll never happen in Postgres. That would be, I think that would be what's called dirty read. So that's dirty reads. That Postgres does not. So in the SQL spec, they say a dirty read means you can read uncommitted data. There's not, as far as I'm aware, like no database actually allows this. SQL Server, Oracle, MySQL, like nobody because this is kind of like the point of having a database with transactions.
It's not allowed by default.
Really, SQL Server does have a flag for it?
Unfortunately, it should have been turned off years ago, but you can still.
Rick, by the way, knows a lot about SQL Server. He is our, I'll bet in this room, I bet you know more about SQL Server than anybody else because lots of background on that, and we work together. But yeah, oh, that's scary. Okay, so I stand corrected. SQL Server can let you do it if you want to.
So I was also going to mention something. I would never use this in a production system, but there is an extension called PG Dirty Read.
Oh, there's an extension. Of course, there's an extension for everything, guys. In Postgres. That is like the best thing about it. Like the source code is easy to hack on, the data structures are easy to hack on, and there's an extension.
And I happen to have known that the extension existed.
Yeah, yeah. Okay, so the solution. What is the solution for this?
Repeatable read.
What's that?
You can make it repeatable read so you get the consistency.
It basically, yes. So you do what's called set transaction isolation level, serializable. So you run this command within my transaction, and this is the command in Postgres that tells you to switch it from what's called the default of repeatable read isolation consistency to what's called serializable consistency. Now I'm in serializable mode. Oh, but I'm in the middle of a transaction. So, you know what's funny? The reason it got that is because I tried to use autocomplete, and it ran a query. I think that's what happened. I might be wrong. Let me try this again. So if I do begin, something happened. The only thing I did was autocomplete. I think that ran a query. Okay, all right, so now I'm going to repeat exactly the same thing that we did a minute ago. So we're going to select count star from attendance for today. We have 2 people. Now, who else is here today besides Rick and Lloyd? Somebody else is. Tanya's here. Thank you for coming. So now we have 3 people. So we're going to, again, insert, now I thought it was 2, so of course my application code, is using, and this is the whole problem, right? Because like if you pull that value down, let's say you use it for something, and then you want to go back and update that row again, but the row has changed, or the values have changed. Like this is what can lead to actual bugs in your application code, and weird race conditions that are hard to reproduce, because you only get the bug if like a concurrent session does something at the same time. Like good luck reproducing that like in your CI/CD pipeline. You can really only if you know exactly what to look for. So we'll stick to this is still not great attendance because we see 2 people. Okay, but now let's query it again. Still see 2. So this time we're not seeing, and that is what isolation levels are. That's like an example right there of what serializable isolation is in Postgres. If you switch it to serializable, now there is an overhead to this. Like it has to, this is actually that last, it's using what are called predicate locks, and it's using that last SLRU cache. It's using that data structure. It has a cache in front of the data structure for performance reasons. Now, how much is the overhead? I know some people in the Postgres community that have told me they run every database and just serializable by default, and it's worked out great for them. Yeah, there are people that will say you can do that, and I believe them. I haven't, but I also came from an Oracle background, so in Oracle it's repeatable read by default, and I'm just kind of like used to that. I think some of it for me isn't necessarily that I've done like all kinds of performance tests or anything like that. It's more just like that's just what I always knew and what I always did, so I just kind of like it never seemed like an issue to me. So if somebody wants to try running all their databases in serializable mode, do it and come back and tell us what you find and try not to burn anything down.
So we do use serializable for some of our databases here.
Nice.
Specifically because we don't want a study to be updated and then one query have analyzed the data set and then the data set to be updated and the next query to do a different analysis on it and have mismatched data. Especially when dealing with study data. So that type of stuff we have to run under serializable.
And that's exactly what it exists for, is for those kinds of computer science problems.
As another example, first of all, because I use ODBC, there's a trick to tell ODBC to go in serials mode. But I use it to actually make backups. So if I want to have a certain snapshot of a bunch of data in a certain way, then I would go in isolation mode. I can do my dumps and ensure that they are relationally matching. So there's no like a parent that doesn't exist or a child exists or something weird like that.
That makes sense for backups, yeah. Who else has questions? Who hasn't thrown a question out yet today? There's lots of people here who love thought, so there have to be more questions. Yeah.
Are there, curious about other databases, how do they solve this problem? Like, do they do it in a more elegant way, or?
You're curious about other databases and how they solve this problem.
Sounds like.
What is that? Are you asking like whether other databases have a different approach to the SQL standard, or if the under the covers implementation of the isolation model is different?
Well, whatever you think is
Whichever is a more interesting answer.
It sounds like SQL Server is inferior in some ways.
No. It didn't. They just
Well,
have an
how-
option that allows you
Yeah.
to turn that on. Well, I mean, it wasn't like, do you think it's inferior? That wasn't the question.
Yeah.
Well, I think one thing about SQL Server is kind of, with the exception of recommitted, all the isolation levels are limited with blocking.
Hold on, say it again.
There's basically no optimistic concurrence in SQL Server except for recommitted.
So-
serializable, repeatable read can all.
So that's partly answering that question. It
Yeah.
sounds like the SQL Server under the cover implementation of serializable isolation is very expensive in terms of, which makes it fairly impractical to use.
It may be inferior.
You do have, I mean, like, that's almost too general of a statement, because I mean, Postgres, like, they're called predicate locks. Like, the word lock is still involved, but you know that. So it's not like the fact that there are locks involved. There are locks involved in everything. That's the only way you can do things safely. But it's more like how you're using the locks and how it's architected and what's the algorithms. Yeah.
Does serialization work the same way in a sharded database?
That's a really good question. Does serialization work the same way in a sharded database? So this is like the question that no sharded database vendor wants you to ask. And it's not because they can't answer it. Like, it's because like when you start getting into the nitty gritty details of like how consistency works, like this is where you have to sort of make all these tricky decisions about trade-offs in every system. And so it's not a bad question to ask. It's a great question to ask, like, you know, developers or vendors or whoever you're talking to. It's super interesting to like get into like different solutions and have different approaches, because people take different approaches to these things. And that's, these days, you know, you've got such a huge landscape of databases. You've got stuff from like, you know, like Dynamo or distributed key value stores to, you got like MongoDB type things to, you've also now got all kinds of like distributed SQL databases that are popping up that have much more sophisticated, you know, now they're bringing back in a lot of the very sophisticated, I usually think of like two big things as like joins and transactions. Like those are two of the hard things to do that often just simply weren't included originally as people started building out distributed systems, and then you have to like figure out what to do with them as you add them in and how to do it. So for serialization, so there's different things. Like one possible way it can be done is sometimes, and this is not just apply to serialization, but it also applies to like transactions and to other features. Sometimes like the property applies within a shard but not across shards. Like that can be one thing that happens, because that's like kind of one way, you know, you're trying to reduce the cross shard coordination stuff, so that can be one approach. And then this is, I think, one of the challenges with distributed databases in general, not distributed databases. It's a challenge with this huge, vast, massive landscape, is that like every system like behaves like a little bit different in really subtle ways. And so for the most part, it's fine, and you can kind of code with the same patterns against most of these systems. But like those little subtle behavioral differences will sometimes kind of get you. They'll sneak up on you. Like just a year and a half down the road, something surprising happens, and you're trying to figure out why did this thing happen. And it's often like hard to reproduce. It's often related to like it happens in production because it's related to all this concurrent activity, and it doesn't happen in a non-production environment. And like often those little surprises just come down to the particular quirks of the particular system you're on, and you just have to learn it, you know, learn what those are. So that's exactly the right question to ask. Like on a distributed system or on a sharded system, like how do you deal with, do you even support it? So a lot of them don't even support serializable isolation. Like that's, and you can just check docs a lot of times or ask, you know, that's a very straightforward question. And if read committed is fine for you, and that's fine for a lot of people, that's not a big deal. Like you don't need it. But that's the question to ask. Like, do you support it? And then the same question you ask: do you support transactions? And then they'll be like, yes, we just added transaction support last year to our distributed database. And then your next question is like, okay, what are the caveats? And they're gonna be like, well, we don't really talk about that. But there's, you know, you got to start somewhere, and usually it'll kind of like start with one implementation, and then things will be added over time. The transactions might not support sub-transactions. Transactions might not be supported like across some kind of a construct, or like across shards or across tables or something like that. Who knows? Just depends on the system. There's a lot of them out there.
That's about the Postgres FTW, whether they're supported down through that.
Whether which thing?
For Postgres FTW,
Yeah,
from
like,
Postgres
you mean
to
like
Postgres.
isolation levels, or
Or any of this stuff.
any of this stuff. I think so. Postgres FTW, what he's talking about is it's called a foreign data wrapper. It's a way that you can take two Postgres databases and kind of glue them together, so you can run a single query on a single database, and like the stuff in the remote database appears like you can just join it right into a single query, as if it was right there in the same database.
And not just Postgres to Postgres, but Postgres to anything.
Yes, Postgres to almost anything. You
Right,
can
but
just,
I'm
like, almost any
specifically
database
asking about Postgres to Postgres because that's
Yeah.
the one that's normally the most advanced of the foreign data wrappers.
Yeah, for Postgres to Postgres, I feel like I don't know. Like, it's going to be case by case. Like, it definitely does do a lot of push down. It'll push down filters. It'll push down aggregates, like to the remote side when it can. My gut feeling, but I might be wrong in this, is that probably my gut feeling is it's not going to push down an isolation level.
I'd be surprised.
I'd be surprised.
I don't know either, but I would be surprised if it could.
Yeah, well, it's not so much they could.
Well,
I'd be surprised if
the
it
other
did.
side, they would have to put it into the machinery, right? Because most
Yeah.
things wouldn't support it.
It's also like, it's not, I don't know. Like isolation levels are one of those things that have been there for like since the dawn of time, but also it's not something like I feel like we really talk about a lot. So I feel like that makes it a little less likely to get attention.
I was just trying to give him the most complete answer for his question.
Yeah.
Because, because that's how part
All right.
Postgres does distribute.
I want to show just
distribute
real
out.
quickly. I want to show a couple more cool things just before I shut off the screen. Okay, we have a couple tables, and I just want to just tease you guys with some neat things that you can do. Okay, so I have 3 tables: attendance summary, attendance, and SEAPUG is what I did. I'm going to drop back out to my shell, and Rishu is starting to show some of this stuff. But okay. One thing about Postgres, a lot of times you can just look at all your environment variables and look for capital PG, and you'll find all the interesting stuff. It's kind of a trick. The PG data tells me where my database is, so I can hop in here and I can see. So all the data for Postgres is stored kind of mostly. It's usually all stored in this one directory. Sometimes it's configured differently. Postgres as a database is remarkably, in my opinion, remarkably easy to like start digging into. It's very accessible. A lot of times the data structures are much more like dirt simple than you would have thought. Another thing that Postgres does, which makes it just kind of like debuggable and easy to explore, like when I worked with Oracle before, and in Oracle, like everything would be like in an Oracle data file, and the data file like had this relatively sophisticated format. Like it'd have headers in it, it'd have all the, like if you just binary dumped a data file, and it'd be very difficult to make sense of what you're looking at. In Postgres, there's a lot, like all the stuff Rishu was just demoing. If you didn't catch this from his screenshots, like they literally just take a data structure and map it straight to a file with like nothing. They don't even do checksums. Like it's so naive and dirt simple. Like you're thinking it can't possibly be that simple, and you're like, oh, it actually is. It's like, so as an example, like the commit log is basically just it's just a giant array. Okay, so you have 4 billion possible transaction IDs because it's an unsigned 32-bit integer. Okay, and so just think of like an array of 4 billion 2-bit values. That's the commit log. That is it. It is just a giant array of 4 billion 2-bit values, and it's just like you can read into it. And how did they format the file to store this array? They basically like memory mapped it. They were just like, we'll just stick it in a file. And then instead of making it one giant file, the one thing that they did do is like, we don't want one giant file. So what we'll do is we'll just take like the first 4 digits of the hex number, and that'll be the file name. So like that's literally how they split it up. So if you want to like, if you're looking for, the commit status of transaction number 2000. Okay, let's just do this. Like transaction, I just pull up my calculator, and I type 2000 in, and I can see in my little hex calculator that 2000 in hex is 70. Like the file name is probably going to be something, actually 2000 is not an example, I need a bigger number. Let's do 200,000. Okay, there we go. That's a bigger number. In fact, 2 million, make it even bigger. All right. The file name is going to be, so in hex, that's 1E8480, okay? The file name is going to be like 1E, and the offset in the file is going to be like 8480. Like that's literally how simple it is. It's not quite like that because remember it's 2 bits. So actually 2 bits, you can fit 4 of them in a byte, 8 bits in a byte. So technically divide by 4, and that's your offset into the file. But it's literally that simple. Like there's no file header, there's no other, they just took the data structure and they just mapped it to the file. So you can do things, that's what Rishu was doing. That's why you can walk into the directory and like he was going into the pg-transaction directory for the commit log, and all he was doing was basically a hex dump of the file, and like you can just do a hex dump and like literally read it. Like that's why Rishu was able to say like transaction ID number 0 is a 4, right? Transaction ID number 1 is also in that 4 because that's the first 4. You just take that, that's a byte. Actually, that's half a byte, so that's only 2 of them. And you just look at what the bits are, and you've got it. So like it's kind of crazy how simple the data structures are. The tables are similar, and then I was going to show just 2 things real quick that I think are. Oops, there we go. Okay. Let's do that. All right. So here's what I'm going to do. Or I'll just do one thing because I think this is kind of a nice little introduction to MVCC and Postgres, and then we'll wrap it up for the night. I'm going to create a new table. Okay, so I don't want to do this. We'll create a new table. We're going to call it, the Hutch because they're awesome and they're hosting and giving us this space. We'll give it again an ID, which is a big int, and a message, which is some text. Okay. So now I've created a new table. Now, what I'm going to do is go into the, one more thing real quickly. So this is my database directory. And we have all these folder names in here. Let me ls-p so you can see these are all folders, right? What are all these folders? Once again, Postgres documentation to the rescue. Postgres documentation. Uh-oh. Am I still in my Google meeting? Or did it somehow end?
I left it. I don't know if that ended the meeting.
Oh no. I don't think so. It shouldn't have ended the meeting. We might have lost our screen resharding. Oh well. We'll survive if we did. Let's do that. All right. Postgres documentation to the rescue, which is where I was. Yes, chapter 65. You don't read all the chapters. You just look up what you want. But this is fantastic. So it has a section called the database file layout. I'm going to click on this, and this is the Postgres docs. It just has a list, and it'll tell you right here exactly which each of these directories are. You can go right down the list. So again, like the transaction one we have at the bottom it's a subdirectory containing the transaction commit status data, and you can kind of walk all the way up, and you can explore this. It's very easy to get in. What I'm going to just show you is something very simple back into the base directory, which is your main database. So this is your tables, the thing that you probably care about the most. All the rest of that stuff is more like metadata types of things. We have 3 directories in here. What are these 3 directories in the base directory? Rishu jumped over it really fast, but didn't actually explain it. I'll explain it real quick. In my Postgres database, I put this on LinkedIn last week. The second worst naming decision in the entire history of the Postgres project was the word cluster.
I keep using that word in like system design interviews, and people are like, "What are you talking about?"
Oh my
Like,
gosh,
cluster.
it confuses
What's a cluster?
everybody. And like, so Postgres uses the word cluster, and they don't mean, I guarantee you, like everybody in this room has the wrong idea about what they're talking about. It is not a cluster like for failover, or like where you can like a HA cluster. It's not a cluster like Kubernetes. What they're actually talking about, this term predates all of that stuff. And what they're talking about is like within a single like set of processes in memory and running on a single server, you can have like several databases. And like MySQL has this, SQL Server has this, Oracle has this, they all have it. Oracle has it now, it took them forever to get it. They call that a cluster in Postgres terminology. It's like your collection of databases is called a cluster. That's what that is. So I'm connected, and that's important, that's really important because in Postgres, certain things are global and certain things are local to a database. Classic example, your login roles are global. So when you create a login role, that login role exists across the entire cluster, all databases. That if you want somebody to only be able to log into one database, you can do that, but you can't like create an identity that only exists within one database. The identity exists across the cluster.
It's not just your login rules, it's all your rules, right?
What's that?
All your rules, not just your login rules.
Yes, all the groups, logins. Well, they're all rules. I mean, they're all the same thing. I just said login because that's probably what most people would be least confused by. Yes. So we have databases in Postgres. If I do select that name from PG database, because my terminal's not wide enough, I have 3 of them. And if I add something, all the system tables have this magical column called the object ID or the OID. You don't get OIDs, you're not special enough, but the system tables do. Oh, look at that, 1, 4, and 5. Those numbers look familiar. Once again, Postgres just like takes the data structures, puts them straight on the disk. The directory name is literally the OID of the database. It's just that simple. And so we're going to look at our Postgres database, which is number 5. Let's go in there. Whoa, my goodness, what is going on here? I've got like, let's see, how many is this? ls wc-l. I've got 311 files. What in the world? Okay, couple patterns. You'll notice they're all numbers, except some of them have underscore FSM and some of them have an underscore VM. Those two are sort of special metadata. You might guess this. The numbers are tables. The FSM stands for free space map. VM stands for visibility map. You can look those up later if you want. Super interesting data structures and Postgres documentation. That's what I'll always say. So what do you think the number might be? So based on previous patterns, does anybody have a guess where that number might come from? Somebody, just guess.
A relation number.
A relation number. It's not hard, yes. Postgres has a thing. So in Postgres, the sort of magical word is they call it a class, which is a little confusing. But a class is the Postgres word for a relation, or, well, it's actually, I take that back. Class is a broader concept. But that's sort of the main place you're going to look for information about your relations, also your indexes, also sequences, also a bunch of other things are also classes. So I'm going to, I created a table. This all started with the Hutch table. What I'm going to do is select star from PG class where rel name equals relation name, Hutch. Oh, sorry, /x, expanded display, try that again. There we go. So, the Hutch table, here we are. Now I have all my metadata about the Hutch table. Remember magical field called OID. Now, in this particular case, it is not actually, you're right, the number. It's not actually the OID though. There's also something called a rel file node, which is again a number. The file node that's the number that identifies your file. So our file node is 16406. Is there a file in here called 16406? Well, my goodness, look at that, there is. Let me clear the screen, make it easier to see. There it is. And there you have it. That right there, it's a 0-byte file, but I created the table. It's an empty table, so it doesn't have any bytes yet, but it exists. That is my table. That's the Hutch table. Now let's insert some data. This is where it gets really fun, and I'm going to blow your mind. If you don't know about databases, prepare to be amazed. All right, so let's describe the Hutch table. Insert some data into the Hutch table. Record number 1.
Values.
Beautiful. Yay, the Hutch.
He doesn't like that word.
Wait, what?
Yeah,
Values.
Yeah, no values.
Oh, you're right. No, we're gonna always do that. But this is how you know it's real. I didn't like practice this. All right. We now have, on Postgres, if you didn't catch this before, by default, it's like an auto commit mode, so every statement just automatically commits. You have to type begin if you want to start a transaction. If you don't type the word begin, it's just going to kind of auto commit your statements. Which is kind of nice. Some people complain about it. All right, so select star from the hutch. If I could learn to type. It's there. It's a beautiful day at the hutch. So, let's take a look at our file. Oh, look at that. It's got bytes. 8 kilobytes of data. Let's hex dump it. We should see some interesting stuff in here. That's not what we expected to see. So, the star, if you don't use hex dump, what the star means is that every other row repeats the first row until you get to the next one, which is offset 2000 hex, which is 8K, at which point the file ends. So we have a file which is full of zeros. There is no data. But I thought you told me once I committed data, if the database crashes even 1 millisecond later, I'm not going to lose my data. But the data is not there. Somebody who is not a Postgres hacker, you cannot answer, you cannot answer, you cannot answer, you cannot answer, you cannot answer. Anybody else? You can't answer Rick either, because you know too much about databases, even though SQL Server. Somebody else explain this, please. Tommy, you're borderline, you probably can answer you. You probably know the answer.
Is there a cache or something?
There could be. There are, yes, there are caches. But if I yank the power, my cache is gone, and I can't lose the data. Did anybody else hear that? Yes. Yes. Say it louder.
Right ahead logs.
Right ahead logs. Logs. Yes. So relational databases, this is a common design pattern in just about every major relational database, that they're very log-centric. So the way, again, SQL Server, Oracle, DB2, MySQL, MariaDB, Postgres, all of them have this similar. In fact, there's what's it called? There's a name for this, like an academic name. I want to say it's like ARIES or something like that, ARIES. It's just related. If somebody who's like really knows the academic side right here, they'd be ripping me to shreds right now for getting all of this wrong. But yes, the basic idea is that you can write things into a log, and as long as it's in the log, if the system crashes, you can replay the log to reconstruct the state. So where is our data? So let's look. All right. In Postgres, if I go back to my handy little documentation, look down here. Right above the transaction directory is one that says pgwall, and that says subdirectory containing the write-ahead log files. Okay. So we're going to go to that directory, pgwall, and let's see what's in here. So once again, so we've got three things. We've got a summaries, we've got archive, and let me just to make it easier. Summaries and archive status are subdirectories. And there's this file, and the name of the file is, again, like a giant number. You should not be surprised by this by now. It's like, this is how Postgres does things. File names are like numbers. And the number usually is just like a dirt simple, it's just some number from an ID inside the database that they've put into a file name. In this case, this number is composed of 3 parts. 1, 2, 3, 4, 5, 6, yep, it's 3 hexadecimal numbers. If I remember right, I think the first one was called the epoch. Is this right? First one is the epoch, right? And then the second one is the LSN?
Timeline ID.
What is it? Timeline ID. Yes, timeline ID. That's right. And then what's the next two?
They're the same.
What's that?
And epoch.
And the second one is the epoch?
Epoch.
And then the third one is the offset, right?
Yeah.
Is the LSN.
Decided to be transaction ID.
Not transaction, the LSN.
LSN and
For what?
upper 32-bit and lower 32-bit.
Yes. So it's 3 numbers. You have what's called a timeline ID. You have what's called an epoch, and then you have an LSN after that. I'm not going to explain all of those right now. The point is, it's a file name. This is your write-ahead log. This is where all the stuff is. And this has got about 16 megabytes of data. So because it's giant with 16 meg, I'm just going to grab the tail. And I'm hex dumping it. I'm just hex dumping the file, people. This is not complicated stuff. And we're going to go like the last 30 lines. And let's see what we get. Well, look at that. Look what I see at the top. It's a beautiful day at the hutch. This is another fun thing. Like the text is not getting encoded or like compressed, which the cool thing about this is, again, like it's so debuggable and so inspectable. Like you can literally hex dump files, and often you can just see the exact string from your table that you're looking for. It's a really cool thing. Now, hex dump is cool, but Postgres does have some much better tools for working with these files. So I do really like being able to hex dump, and I enjoy using these sometimes. Oh, and before I jump to the other tools, I want to show one more kind of cool thing, which is, let me make a new tab real quick. Now I'm back on my laptop now. I'm just kind of showing off a cool project, but over on GitHub, you can find this thing called PG Hex Edit. This is Peter Gagan put this together. Super cool little project. In fact, let me just pull up the GitHub page. Here it is, Peter Gagan/Hex Edit. It's a nice little, it's a very clever little file that what it does is it's kind of this glue. There's this neat utility called WX Hex Editor, which is a nice graphical hex editor for Linux. And what this does is this thing here can understand all the Postgres data structures and feed that information into WX Hex Editor. So it's really easy. Open Postgres relations in a hex editor with tags and annotations. This is what it looks like. So it looks something like that. And then it's got a bunch of stuff. It builds pretty easy. What I'm going to do is just sort of demo it right now. In fact, whoops. So in order to do this, export PG host equals localhost, export PG username equals Postgres, export PG password equals SEAPUG. All right, now if I pSQL, I should get in. My username field, PG.
PG user.
You're right, just user. Thank you. All right, so we're in. So now, if I pSQL/d, I've got a couple relations here. What I'm going to do real quick, I was messing with the SEAPUG table earlier. Insert into SEAPUG. I can just do a select, right? I think I can just do insert into SEAPUG, and I can just throw a subquery right on it. Select. Oops. Generate series from 1 to 1,000, and then lots of rows. Let's see if this works. I don't know if I got my syntax right. I did. It worked. Look at that. All right. I just put a bunch of data in the table. That was lucky. All right. Now I'm going to pop out. That was the SEAPUG table. /relation hex edit SEAPUG. Oh, there's one more thing I need to do. Create extension, and it's going to do page inspect. All right. Now I run this. This connects to my database remotely over port 5432. It opens the database in this visual hex editor. What's really cool about this is, if I hover my mouse, it understands exactly what the data structures are, and it's able to decode them. So on the right hand, I see the ASCII, and you can see you have like lots of rows. So you actually see the tuples that are stored. This is the hexadecimal dump of the data block that is containing my table in Postgres. All right. And in this, now in the table files, there is a header. So there's a header at the top, and then down here are my actual tuples, my rows of data. And you can see lots of rows on the right. What's cool about this hex editor is I can open it in the hex editor, but as I hover my mouse, it understands these first 8 bytes are an LSN, and it shows me what LSN it is. This right here is a page checksum. It shows me what the checksum is. That is what's called the PD flags. This is the PD lower and PD upper. This is the PD special. This is the page size version, the Bruin XID, and then now we get into the item pointers, I think. If I remember right, that's what these are. I think these are the item pointers, and then it's showing the attributes of each item pointer. And then I can drop down here, and I can see for each tuple, the actual fields of the tuple. So this is the xmin, the xmax, which is invalid transaction ID, this is the command ID. So this is super cool, and my favorite thing about this is, like, a lot of people don't know this. You can do this with, like, even with Amazon RDS. You can dump, this works, I'm not kidding. Because it works through page inspect. You can't dump like the system tables, but you can dump your user tables. So it's really cool. You can actually point this at like a remote Amazon RDS Postgres database, and then you can pull up the raw blocks underneath your user relations right in a visual hex editor like this, and you can inspect. You can see like the XIDs, the visibility information, the flags, all that stuff if you ever were trying to debug or troubleshoot something really tricky.
Does it also play nicely with Aurora serverless, or?
Not yet, but you should pass through them about it if you're using it. It's the thing that you need to ask for is just page inspect support. That's all. So last I knew, they didn't support it. That's an extension. It's a Postgres extension. It's a pretty neat one. There are certain things that I think it is very useful for. Just like an example of what I've used this for is that, like, on a system where there was a lot of pressure for multi-transactions or sub-transactions, some of those SLRs Rishu was talking about, by looking, so there's no really easy way to sort of, you have to use page inspect and look at the data structures to pull out the multi-exact IDs. And if you want to actually figure out, like, what's the distribution, what's the spread, where is all this pressure coming from, like which transactions are creating multi-transactions, like you have to be able to look at the data structures to do that. And I've actually done that with page inspect. I've actually done that on RDS with page inspect for troubleshooting those kinds of situations. So the thing, if there was a use case for it, go to your account manager and be like, hey, put this on your roadmap, give us page inspect, and you can see what happens. You know, they do. In my experience, the customer feedback stuff does make a difference over there. So it's good for them to hear. Okay, so that was that. That's what I want to show there, the hex editing stuff. The last thing I'm going to show before my battery dies, and it's also getting late, you don't want to go home, I'm aware, is the fancier tools besides this. So you've got PG wall dump, number one. PG wall dump has got a bunch of different flags you can use, but I'm not going to do any flags. I'm just going to dump the wall file. We'll do like the last 30 lines, and that will take, and rather than dumping it in hex, this will interpret all of the information out and like show you the individual records in the wall file. And then you also have a equivalent thing, although here's the trick. But we never finished our story, did we? Where I left off, you talked about the wall log. So select star from Hutch.
But you inserted a lot of rows into it.
Ah, yes, now it got pushed out. So now my data has come down, but okay, I want to do one more. Record number 2, it's still a beautiful day at the Hutch, okay? Not there, right, not in my table. By the way, notice, kind of small little point here, but there's a header at the top. Where did the row go that got inserted? All the way at the bottom. So Postgres blocks are always, it's actually, you can compile, it's a compile time flag, so some people will do their own custom compilation and change it, but if you're using standard Postgres, it's 8 kilobytes in a block, always. That's how all the data files are laid out, 8 kilobyte, 8 kilobyte, 8 kilobyte blocks. The header is at the top, and then there are something called item pointers, which are really, really tiny, and they just sort of like fill in from the top. There's one item pointer for each tuple, and the tuples are at the bottom. So the way the block works is that the actual data starts at the bottom of the block and works its way up. Your header and your like metadata starts at the top of the block and works its way down. So this is great because it gives you a bunch of flexibility where you don't have to try to like, they'll just meet wherever they meet. If the rows are really wide, because rows are variable length. So if the rows are really wide, it can use efficiently use all the space until it gets up to the item pointers. If the rows are really short and narrow, you can get more rows in the block, and they'll just meet at a lower point. So that's how it works. So, last question of the night. Who can tell me, so we know why the data's, we know where the data, we found it in our write-ahead log. But when does it hit the block? Because this is in the block. It did eventually get written to the block. So when does it hit the block? That's question number 2. Any guesses? Ross, you can't answer this one because you answered the last one. So. Somebody else has to guess on this. Hold on, over there.
Is it when the write-ahead log is like full? If there's some like limited size that's allocated to that log?
Close. When the write-ahead log was full was the question. Sorta. I mean, not really. It doesn't really fill per se.
It's not like-
but
it's
I feel
like
like you're on the right track, sort of thinking about the write-ahead log.
So here we are looking for when what is happening.
The question is when I added a row to the table,
Yeah.
row number 2. It's not currently in the data package. It's still not there. If I go in here and I hex dump the file, it's now something came through and did it on me. I waited too long. Now I have to go insert another row, guys.
Something in checkpoint from you.
Thank you.
Wait, not like
You were supposed to answer. Yes, you got it. What did you say, Ross?
checkpoint.
Yes. So if you haven't heard of it, in Postgres there's a thing called, not Postgres, every relational database, SQL Server, Oracle, MySQL, DB2, all of them have this. It's a thing called checkpoint. Aurora does not. So when you get into like the distributed world and some of these like re-architected databases, the architecture can change. There are some others too. But any like traditional relational database, if it has a checkpoint process. If it has a wall log, it probably has checkpoint. So what is checkpoint? I'll show it to you if I type the word checkpoint over here and I press enter. Now I come back and look at the data file, there it is. But why? The question is why? Anybody know?
Performance. Like, I mean, it's sort of like a cache, right? The write-ahead log.
I don't know if I'd say cache. There is the cache. There's the buffer cache.
There's a wall cache too, right?
There is I think there is like a write-through cache for the wall, but like there is caching involved. But I don't know if I'd say, I don't know. It's because performance is vague enough that I can say you're correct in some way. But why specifically would be the question.
Well, what is the question?
The question was just why when I type checkpoint, then the bytes showed up in the file. Why was that the case?
Is it because when you do a checkpoint, it takes the snapshot of the database and the wall goes away?
Say that again.
It takes because it's using this file as the snapshot and no longer relies on repeating all the wall transactions.
It no longer has to replay the wall transactions. That is exactly right. Yes, you're right. That is exactly what it is. And the question comes back to sort of like, when can you remove the wall? When do I no longer need it? When is it sort of safe to say I don't need it? Because we persisted it in the wall, so we're safe. If there's a crash, it won't be lost. We can replay the wall. We can reconstruct the state of the system, right? But that does mean you can never delete the log. It would get really big. And we do eventually want to kind of like flush the data down to the regular data files. And once all the data has been flushed, at that point, we no longer need the wall. There's another like really important implication of this, which is how long does crash recovery take? So like if the system does crash, and this is going to impact your RTO, your recovery time objective, which is to say if there's sort of an incident, like how quickly can I get back online? 2 key database numbers, RPO and RTO, like you'll hear these, you should know what they are. RPO is recovery point objective, and it's how much data will you lose. And RTO is recovery time objective, and that's how long will it take you to get back up. And this is sort of like databases 101, but it's super important fundamental concepts. You might be thinking, why are you talking about data loss when you just said you can't lose data? Typically, when people talk about RPO, it's in the context of, let's say that I lose all the storage. Because the other thing that's typically happening is you usually have a backup system, and those wall logs are typically being streamed off to the backup system as well. And so there's another question of like, let's say I lose the entire server, right? We're running on EC2. EC2 had a bad day. They shot my server in the head, including the EBS volume, and it's just gone, the whole thing. How much data did I lose? There's two answers to that. Number one is if you have like streaming replication, like with maybe just a lag of a couple seconds, then then in that case your RPO is whatever your lag is. So your RPO might be a few seconds. The more traditional thing is maybe I'm not streaming replication off, but at a minimum you have a backup system, and typically like between 1 to 5 minutes, you take the wall logs and you just copy them up to an S3 bucket or something like that, or wherever your backup system is. It could be your Commvault backup, software as well. Like this has kind of been around forever. So if you're pushing the wall logs, if you're backing up the wall logs every 5 minutes, then your RPO is 5 minutes. Sorry, your RPO is 5. You could lose up to 5 minutes of data because the wall logs are off the system every 5 minutes. So that's your, so yes, you're exactly right. It shows up in you what a checkpoint is. It's basically kind of reconciling everything in the system and saying flush everything down to the disk. That basically all the wall logs before now are now safe to remove. Usually you have a second thing, which is you don't remove them until they've been backed up. And so typically those are kind of your two variables in a database is, first of all, you have to get the checkpoint done so that they're no longer needed for crash recovery. That's like the most foundational basic thing. But then after that, you also make sure they're backed up off the system. Now people don't wait, like typically backups will grab the wall, siphon them off the system like as quickly as possible. You're not waiting for checkpoint for that. But that is the answer. The one last thing I was going to show was there is one more kind of cool utility. This is the data file here. This is the one, I love this utility. And this is not included in standard Postgres. You have to install it separate, even though it is at postgres.org. It's kind of weird. There aren't many of these, very few of them. But this is a super useful utility hosted at git.postgres.org, and yet somehow not included in like core Postgres. It should be, in my opinion. So PG file dump. So I can PG file dump. What this is a thing that will actually dump out it's the sister of PG wall dump. Wall dump dumps out your wall files. File dump gives you the user-friendly dump of your regular files. What was my file name? 16406. If I do this, there you go. Now it's, rather than looking at a bunch of hexadecimal stuff, this is giving me my actual data structures. See 3 items that are in this block. And then it has a couple extra flags, which I jotted down so I can remember them. Okay, so if I throw a -f, this is fun because now I'm actually seeing the same hexadecimal bits, but they're lined up with the tuples. So item 1, item 2, item 3. So this allows me to kind of, again, it's a beautiful day, it's still a beautiful day, it's really nice. I got all 3 of my records. The other 2 fun ones, the -i, this is fun. This sort of decodes further some of like the flags inside the items, and it's telling me the actual like constants of what the flags mean inside of the boundary bitmaps. And my very favorite, which is the tuple decoder, I can do this, say decode the tuples. I have to tell it the data types because it doesn't know, it doesn't have the catalog and schema information on hand. But if I tell it, it's a big int in text, watch this. It can actually extract the data. And there's the number 1 and then the text field, number 2 text field. And the reason it says copy is that this is designed so that you can grep for the word copy, and then you can feed this directly into the copy program, and it's formatted correctly for you to read it straight back into the database. And the reason it's done this way is that this is a data recovery tool. If you have like a corrupt data file, if you have bad checksums, if your disk flips some bits on you and the database is refusing to load it, and I have seen, this is rare, but I've seen it happen. You can have some kind of a problem at the disk layer or the disk subsystem layer that like screws up a couple of blocks. But I've seen this where the blocks were partially screwed up and there were a couple of bad bytes written in the block, but I was still able to extract other rows from the block. This is a super cool tool that you can just take, dump it out. You do have to figure out, again, you have to know, you're gonna have to go through the data because there could be, this is just a raw dump. Some of these tuples might have been deleted rows. You don't have the commit status and the transaction status. But as a tool of last resort, if you just want to like rip data out of a file, because sometimes if there's no other alternatives as a last resort tool, it's a super cool thing to be able to do. To be
You
able to
can,
dig in
you
there.
can probably demo that if you want. You can
What's
just,
that?
you could probably demo that if you want. You can just open it in Vim and add a character.
I could, but I'm not going to because it's 8:10. It's as much fun as it will be. That there is a demo on my blog though that you can cut and paste right through, showing how to do like just writing some random bytes into a file, corrupting it. I didn't go through like the recovery thing, but it links back to some of the stuff. Questions? Thoughts?
You said that Checkpoint is not available in Amazon Aurora.
Which is kind of a lie, but it's kind of true also.
So maybe it's too much to get into, but why is it not available?
So it's kind of a lie, kind of true, because hang on. Hold on, what's public information?
Oh, sorry. Yeah, maybe. Yeah.
It's fine. I can say with that, like, there is still like technically a checkpoint process that runs because the checkpoint process in Postgres, and you can look at the open source code. It has a lot of jobs. And it has to do a lot of things, and like flushing the blocks out to the disk is just one of many jobs.
Yeah.
So in Aurora, you don't need to flush the box out, and the reason for that, like this is just fun. It's just the architecture of Aurora. Like you can go read the paper from the ACM, and when they walk through how it works. So Aurora is feeding change records down to a purpose-built storage tier. The way I like to think of it is in Postgres you have hot standbys. And so the way a hot standby works is the wall log is just streamed to the hot standby, and the hot standby is running in crash recovery mode 24/7. That's all it does. It just sits there, it reads the wall, and it runs the Postgres crash recovery mode code, and it just replays the wall logs. That's how it keeps the standby. So this is, by the way, also the difference between physical and logical replication. This is why we talk about physical and logical replication. Physical replication is a Postgres hot standby. And what that means is if you log into a hot standby server and you hex dump the data files, they will look identical. It's the same bits in the same place. Logical replication means what I'm seeing is like insert record into table, but like the physical representation with logical replication doesn't have to be Postgres on the other end. You can have logical replication that goes from Postgres to anything, to Snowflake, to Redshift, to MySQL, to Oracle, like any data store. You can have it stream it into CSV files if you want, or I don't know, like what's the Parquet files on object storage. You can stream it anywhere. So logical replication, you can logically replicate from Postgres to Postgres. That's really, really powerful, especially for things like major version upgrades where you can't stream it physically, stream the wall because of format changes. But it's a fundamentally different thing, different architecture. Physical replication, we stream the wall, we play the bits. So Aurora is what I was getting to. One way to think of Aurora is like the entire storage tier is just like a fleet of hot standbys. It's kind of what it is. It's just getting wall records. It's not exactly what, they're not actually like exact wall records, but like conceptually, like it's a way to think about it that kind of like gives you an idea. So if you think about that, if it's just getting the change records and it's replaying, there's no checkpoint because it's replaying the records in real time constantly all the time. So the blocks are already empty.
What's cold standbys?
They're cold standbys.
Cold storage. Like no one's reading, you're not reading directly from storage.
They are kind of, because they're like a storage tier. So like you have all the like every time you have to do a block IO, you go down there and get the block and it comes back up.
But
it's just you're reading blocks instead of queries.
I think when I think of hot standby, cold standby, I'm thinking hot standby means it's actively serving requests.
Yes.
Like no one's querying
Fair.
Aurora storage.
Totally. Yeah.
You're only querying Postgres or MySQL instance.
Yeah.
And so that's the whole reason Aurora works is that you can replay these blocks in parallel and they don't have to be correct. Like they don't always have to be in the correct order.
Yeah, it's a different architecture. It's interesting.
So there's one of the cool things about Postgres in general is because of the very open licensing. And it's not just the licensing, it's also like the community has been receptive and like willing to go along with it. Like there's just, it's basically BSD licensing as opposed to GPL. It just makes it very, very easy for anybody to come along. And MySQL's had this too over the years. But like just loads of people just pick up the code and then like do stuff with it and come up with all kinds of ideas. Aurora is one example, but there's lots of others too. Both with MySQL and with Postgres, where people like kind of like you take the code and maybe use a little bit of it, maybe use a lot of it, and they kind of come up with like interesting and novel ideas to build new database systems based on it.
So another question on different databases. You talked a lot at the start of this about how it's different in Postgres how a transaction can span tables, and that's surprising to me. Is that not true in other databases?
Not all distributed databases.
Okay.
Yeah, like a traditional relational database is absolutely, but like this is like the whole NoSQL thing. NoSQL, like a lot of NoSQL systems were, I feel like going back to basics and like sort of rebuilding, but like saying, let's if we can just like narrow our use case, instead of trying to support like all this stuff that SQL does, which in my opinion, a lot of that just sort of grew out of experiences that a few people had. It was like the success of the relational model in a way. Because it was so successful,
right?
People ended up with these massive, brittle, like huge monolith databases, and then stuff happened, like they had outages, they did a DDL thing, and it sucked. And then like, it's just, you had a couple of these, especially at really, really, really like, hyperscale companies, Amazon being one of them, and it's not AWS I'm talking about, it's like Amazon.com, right? And it's not, Salesforce, eBay, like look at all these like web companies that a lot of them were using Oracle. And they just all of a sudden had like literally millions of people slamming their websites. And that was just not something, that was kind of something new that happened with the internet. So like that went on for a while, and Oracle is amazing. And I think it probably, along with everything else, just drove the continued like engineering on the Oracle side, and that's an amazing database. But the scale is hard to keep up with. And at some point you're like, maybe we just need a distributed key value store. Maybe that's all we really need for the shopping cart. Maybe we don't need all this other stuff. And maybe they're not wrong, right?
Oh yeah.
But also the microservice concept architecture try to break down the data because each service owns their own data, which is kind of difficult to deal with the database that we have.
I think that's sort of the same of like, it's just like the, it's like the success of the relational model in a way, it's just like, it's so successful that it's killing itself in a way. It's just like, it gets big. And like you just, at a certain point, like when you try to support this expansive feature set, which is what it really is, and then when you also have huge data sets and really high traffic and like heavy workloads, that's just, I don't know. That's also like, in my opinion, where you get the really interesting computer science problems. And like, these are the fun systems to work on. But yes, that also drives, they're fun problems, but also like, who wants to like really be, getting paged every weekend? At some point you're like, just have microservices and let's live normal lives and not have to worry about it, just keep it simple. And this is what I'm seeing with Postgres in a lot of places. Like with Postgres, a lot of people have figured out like, it's, from an engineering perspective, I don't try to tell people that like Postgres is Oracle. Like, it's not. Like Oracle has some amazing fancy tricks that it can do. But on the other hand, a lot of people, Oracle like famously, like really sold real application clusters really hard for like 5 years, convinced everybody to buy it. And like its list price is $20,000 a core for rack. That's list price. Yeah, that is nuts. Now nobody pays list price, as like sort of dirty little secret with Oracle is that everybody knows that nobody pays list price. But it's very expensive. And a lot of the people who bought it, just because salespeople were trying to hit quotas and get their bonuses, like didn't really need it. And so like at some point, like that works for a while, but at some point like people kind of start to realize like I'm paying a lot of money for something and I could just use like a failover and a standby and it would have given me everything I needed. I didn't really need this like, super high availability for my internal departmental web server when everybody goes home every weekend and nobody's hitting it anyway.
But I mean, when they were selling rack, right, Postgres was like, why do we have two-phase commits? What's the point, right?
There's also that.
And so it's
It's
cut
all
off.
this in parallel.
It's
Postgres has matured a ton in the last like 10 years. I think it was always pretty good. But
it wasn't always pretty good. It's grown.
It's growing. Yeah, the wraparound problems, like, thankfully, are much better now. But you could, I don't know, people were running on Postgres 15 years ago. Not like now.
Oh, for sure.
But there were people running on it successfully, and they weren't going out of business. At least some of them. And the ones that did was for other reasons, not because of Postgres.
So you did talk about PG file dump on there, and that will allow you to look at corrupted pages and get the data out. But one other thing that people may not realize is you can start up Postgres in single user mode and tell it to ignore corrupted pages and then be able to do a dump of your table, and it will skip any corrupted page within the table and get you out all your good data.
It's tricky though, right? Because if you're missing C-log commit data, it's not. I don't remember being able to know what to do then.
Yeah, I know somebody who's actually had to do it, and so that's why I know that you can do that.
All right, it's 8:20. Thanks everybody for hanging out. I'm gonna hang around for a while. You're welcome to. We can hang out and chat. But some people probably want to get home. So.
Because people who have questions for senior DBAs, we're here to answer questions.
Alright, I need to remember for next time. The recording too? Yeah, well, I have a suspicion that as soon as we share the call, I bet you it shut off the recording. So I bet I lost my screen capture for so that probably won't go online, that part.
I'm glad I keep them.